We have already finished chapter 4 about, and we talk about the fundamental theorem of calculus. Then,
Yeah, I have like few confusion about the last lecture.
okay, and after fundamental theorem calculus, we learn how to apply the substitution rule. So, this is the major development which we have
Yeah,
done after FTC. FTC was telling us the purpose of integration, the geometry behind the integration, the concept behind the integration. And when we got a grip on the FTC and we knew the basics of the integrals and the concept behind the working of integral, then we tried to learn new techniques to solve complex equations in the integral. And the most efficient is the substitution rule. We will do some other techniques later. and another one is the, if you recall the product rule in the differential calculus, so the same rule we have in the integration, and it is called integration by parts. So that is also another technique. But so far we are going to apply the knowledge which we have achieved on the basis of these two topics, and we are trying to apply this knowledge into certain geometries, certain fields, and like this today lecture and maybe the next lecture, we will try to apply the knowledge which we so far we have achieved for the integration using these two things. And we will try to calculate the area, the volume, but this time the area will be a kind of a different shape. When we started the integration, we said, okay, if we have a curve like this in a certain plane, then we decided the boundary and we said we want to know the area of this region. So the whole thing was based on one curve, one function f of x. So the whole concept was based under this curve, and we said that we are finding the area under the curve. So this word was important. In the first session of this advanced mathematics 2, we have done this. Now the concept is the same. Things are in the similar pattern, but geometry is changing. Previously the geometry was this, this, and only this part was curved. So you can see the left side, right side, and the bottom, there are the straight lines, and the only curved geometry is the upper side. And we said that This geometry belongs to a certain function f of x. Now, if we have two functions and they are traveling like this and another function traveling like this, so now, and they are intersecting each other at certain points, for example, these two are the intersection points, and this whole thing, suppose this whole thing lies like this. This is the x-axis and this is the y-axis. So you can see there are two functions which are inside the frame. We have two functions in our frame. I'm naming first one as f of x, this curve, the curve like this, the upper curve, which is like this. So I'm naming this curve as f of x. And the curve coming from the bottom and going like this, I name this curve as g of x. So we have two functions and that both the functions are making curves like this. Now I am interested to know the area of this region, S. And this region comprises of two parts. One part above this line and one part is below this line. And you know from the same here, when we were having a curve like this and it went like this, and we said if this is the x-axis, then we said okay, this will be the area 1, this will be the area 2, and this area will be given a negative sign because this is below the x-axis and this is above the x-axis, so a1 will have a positive sign when you are calculating them together. Similar is the case here. The belongings of this function will be considered with a negative sign, and the belongings of this function will be given a positive sign similar to that. The formula is same. Can you tell me the Rayman sum formula for this shape, which we have done previously? What was the Rayman sum formula for this shape? Area under the curve. You have to give me. Summation
n is equal to
I from 1 to n.
Yeah.
F of
F of x.
xi steric.
Xi
Delta x.
del x.
So this was the formula for calculating the Rayman sum of a curve having this shape, and which was the single curve, and when we were talking about the area under the curve. And to calculate the area under the curve, we said now this was the sum of the small slices which we made like this. So the areas of all the slices, when we sum them together, it becomes the Rayman sum. And to know the total area, this is a summation of some finite number of slices from 1 to n. And to calculate the total area, we say that this n should approach infinity. And we said yes, the total area will be limit of the Rayman sum, limit n approaching infinity of this whole thing. So this gives us the area under this curve for all the slices combined together, and we are assuming that there are infinitely many slices. The same concept is shifted here, and we are going to make the same building of the slices like this. And nothing changed. This is same, but in addition we have the bottom also, and the bottom is representing the curve g of x. In this case, the bottom was a straight line, so there was no curve. This bottom was a straight line, no curve. But here we have the upper part is also a curve, the lower part is also a curve. So the same formula is going to shift, and the area of this region S. What was this area? This area was the area of this region S, which is inside these whole slices. The same concept is shifted, and the area of this region inside this whole geometry, curve geometry, is limit n approaching infinity, summation I from 1 to n. The first function f of xi steric minus, I told you, the upper function, and one condition. I will write the proper definition later on for the area between the curves. This thing is happening for the area between the curves, and this was area under the curve. So area between the curves, for these f and g, there is a condition. The function f and g is continuous. You know, in integral, we always talk about the continuity of the function which you are putting under the integral because of the FTC. FTC violates if any of the function is not continuous. So if FTC violates, whole integral calculus is failed. So you cannot violate FTC. Whenever you are considering any functions, f, g, h, I, j, k, l, how many functions you consider? If any of the function violates FTC, there is no meaning of the working which you are doing after that. So FTC says all those functions are continuous. Continuous where? Between the given points. If I am interested between these 2 points, and the next point is this is B. You are always talking about a certain domain, A, B. So you have to fix those A, B, and in between those A, B, the functions should be continuous. So f and g are continuous such that the x belongs to the point, to the interval A, B. For any value of x, this x, any value of x in between these two limits, the functions are continuous. Outside, even if the function fails somewhere, there is a discontinuity, doesn't matter. This interval is important. Within this interval, there should not be a discontinuity. So these are the conditions on the functions, and the function, the second condition, this was the first condition, and the second condition is that this function in between the interval is always on the upper hand as compared to this function. Now for example, if the two functions are going like this, for example cos theta and sin theta, we will solve an example also, but I am just telling you, if one function is going like this, the zigzag curve of the cos theta, and the other function is going like this, the zigzag curve of the sin theta. Now if I am interested to know if this is the, say this is the x-axis and this is the y-axis. Now if I am interested to know the area in between the region, if this is A and somewhere I am saying this is B. Now look, if I say this is my f of x and the lower function, this function is g of x, then up till here the f of x is on the upper hand of the g of x, and the condition is that the f of x is greater than or equal to g of x. The f of x is never less than g of x. If f of x is less than g of x, it will shift like this. Now move to this part, because my whole domain is here and I am interested in whole this region. When both the functions will cross this point, now f of x is on the lower hand and g of x is on the upper hand. This condition is violated for the second half. In that case, what you do? You split them into two. You separated 1 and separated 2. And for this one, you assume that f of x is greater than or equal to g of x. And you solve this equation which I am going to write. And then you keep it as area 1. You say this is the area 1. You keep the value. Now, for this one, you will switch the function. And you are going to tell me that yes, g of x is greater than or equal to f of x. In that case, in this region, forget about the area 1, forget about it. Only in this region, now this function will be in the formula, will be written first with the positive sign, and this function will be written second with the negative sign. So now I am going to write the full-fledged formula to find area between the curves. The upper function is f of xi steric. The lower function is given a negative sign, gi steric into the delta x. And you don't need to apply the limit. First, you are going to find this thing. And when you find it, you apply the limit on it, and that is the area. But now, the good thing is that we are not going to use this for this part. You can do it, but we don't need to do it because we know the concepts of Rayman Sum, and we can do this. If we can do this f of x, you know this how to do, then you can do it for them, both of them also. I am going to write the relevant integral formula for the same. So the purpose of telling whole this thing is that the concept is same. Here, when it was a one function, we started with the Rayman sum, we applied the limit on it, and we said this is the area, and ultimately we said that this whole thing means the area under the curve is integral from a to b f of x dx. Remember? We started from this, then we extended the whole thing to the limit, and we said yes, this is the area under the curve using the concept of slices. And furthermore, when we talk about the integral, we shifted this whole formula to a new version which was under the two limits integral f of x dx. Similarly, we can start from this as a Rayman sum, and then we can apply the limit on it, and when we apply a limit on it, it becomes area in between the two curves using the concept of Rayman sum. This is the Rayman sum of the difference of the two curves, and this leads us to the integral formula, which is integral from a to b. The limit points are important. A to b f of x minus g of x whole dx. I can give you a question to solve this, but I'm not going to do it. I'm not going
So
to.
we're gonna also separately solve them, right?
Yes, I
And
don't
apply
want.
limits.
Yeah, I don't want to put the burden on you. This we will just follow this formula to calculate the area under the curves. But the concept is coming same. Now you
I'm
know.
saying in the final formula, we can solve them separately as well, right?
Of course, we will do example, and you will see that you have to apply separately, definitely.
Okay,
if they
and
function.
the second case,
In the second case, you will switch this.
yeah,
This will be the area 1,
yes,
and in the second part it will become the area 2 will be integral from. Now when you have this kind of situation, then of course you will split the interval into two parts. From here, that whole interval was what? Okay, say here, this was the whole interval from a to b, and they are switching at this point, suppose c. Then if you have this kind of situation, this formula is for this situation when they are not switching in between AB. When they are switching in between AB, and you are finding area 1 first and area 2 second. Then for the area 1, the limit point is from A to C. So you will separate the limit points also. Your whole domain is A to B. But
Yeah.
from A to C, the things are different. C to B, the things are different. So to calculate area 1, you will apply the integral A to C f of x minus g of x dx. This is done. Whatever the answer is, you will save it. And to calculate the second part, when they are switched, when the g of x is above, it will become from C to B. And now g of x is on the upper hand. And f of x is coming from the lower. So it will be g of x minus f of x into dx.
Whole dx.
This will give you a value, this will give you a value, and the total area is A1 plus A2.
We will just add them.
Yes. Because
okay, if we have multiple splits, more than 2, 3, and
yes,
we will do the same.
You can go.
Okay, but they will always switch the f of x and g of x after each interval, right?
It depends
like
on
for
the
one.
It depends on the nature of the function. Sometimes there are some functions, they switch one time, they switch like this, and after that they never switch.
Right.
So it means you only need to calculate, this will be the area 2, this will be the area 1. You only need to calculate 2 areas. But cos and sine are the best examples which are switching after
every interval.
Because they are opposite to each other, the zigzag. So the proper definition using the concept of FTC for the area between two curves. First we were doing area under the curve, so it was one curve. Now area between two curves. The definition says the area bounded by the region covered by the two curves. Let's say one is f of x and the other is g of x. And the lines x equals to A and x equals to B. You can see if you have two curves like this, then if this is the plane, then the point x equals to B gives you a vertical line. Similarly, okay, let us change the shape a little bit more, and this it's like this. Similarly, if this is the point x equals to A, then it gives you a vertical line. So that is the meaning of these lines. The lines x equals to A means this line, which is going from x2 towards the y-axis, and the line, this one, in between this region. So area bounded by the region framed by the curves f of x and g of x in between the 2 points x equals to A, x equals to B, such that f and g are continuous and the point x belongs to AB. The function f of x is greater than or equal to g of x. Then area between the regions is defined by A to B, f of x minus g of x and dx. Now whatever the functions are, you can use this formula if this condition is valid. If this condition switches, switch these functions here. If g of x is greater than f of x, then switch the functions here, g of x minus f of x. The function which is above will always be considered as the first function, and the function coming from the below is always considered as the second function. And sometimes we call this line as the bottom line yb. So yb simply means the lower function, and in this case the lower function we are naming it as g of x. Similarly, the line coming from the up is named as y top. and the y top means f of x. So if somewhere it is written yt, no need to get confused. Yt means f of x, the upper function, top function, and yb means the bottom function, g of x. So whatever the name of the functions are, they are the top and bottom functions. So the here in this formula, the top function will be written first, bottom function will be written second. And a special case is in this formula. Let us switch back to the actual scenario. If in this formula, if g of x is 0, a constant function, then you can replace this formula by 0 and it becomes integral a to b f of x dx, and this is exactly area under the curve, right? This formula is for area between the curves. Now, if there is no lower function, or if the value of the lower function is always 0, it is giving you a 0, then it means you can skip this and it reflects back to the actual formula, which is area under the curve. So this is just a special case. If you want to go back from here to the area under the curve, simply put g of x equals to 0. Find area bounded above by the function y equals to x square plus 1 and bounded below by the function y equals to x, where x is from 0 to 1. So they said the function which is covering the region from above is this one. So I can say, let's say f of x is x square plus 1. And the function coming from the bottom is this one. So let me say g of x is x. Now if I want to draw this shape, this y equals to x, it means this is a straight line. Whenever x is equal to y, it represents a straight line. So if it is starting from 0 to 1, and if this is your coordinate system and this is 0, if this is the function y equals to x, then it will be like this, a straight line.
Yes.
If you put x equals to 0, you are here. If you put x equals to 1, means y equals to 1. So you will move a 1 unit further here, like from here to here. Similarly, a 2 unit. Every value will give you the same 2. So you are actually moving from 0, 0, then 1, 1, then 2, 2, then 3, 3, and so on. So this is always a straight line. Both the coordinates have same value. Anyway, you know these things. If you don't know, I just wanted to explain. So this is the curve for the this is the function for a straight line, and they said the function coming from above is this one. So how to plot this function? If you put x equals to 0, then the y will give you 1. It means it will start, suppose this is 1 on the y-axis, this is 2, this is 3, and so on. When you put x equals to 0, the corresponding value is here for this function. Now, if you put x equals to 1, the corresponding value for this function will be 2. So, it means it will go like this somewhere. Anyways, you can sketch it. We don't worry about that. Now my region of interest is between 0, 1. X is 0, y is x from 0 to 1. Suppose on this x-axis, this is 0 and this point is 1. I want to extend it so that you can watch it closely. If this is 1, then the region of interest is this one and this one. This whole is the area which I want to calculate using these two functions. This was just an explanation to tell you, and it was, if you keep 1 here, then it will become like this. So I expanded the 1 so that you can see, watch it closely. This kind of a shape is coming from these two functions, and you are supposed to find the area for this one. Why this is bending? Because when you put 0, it is 1. When you put 1, it is 2. When you put 2, it becomes 2 square 4, 4 plus 1 5. So the value is increasing gradually. That is why the upper one is making a curve and the lower one is a straight. When you put x, whatever you put x, the same will be the value of the y. But in this case, the value is increasing with this number. So every, and this is a square, so every next value is changing, and here every value is same. You don't need to worry about all these things. This is just an explanation. If I give you the question, just put these values into the integral formula. This was,
so x approaches to 1 is the interval.
yeah, this is the actually the interval AB. So my A is 1, A is 0, B is 1. Now that is here, x0, x1. So only this region. So the formula says to calculate area under this region. Now there are two curves. One curve from the bottom, this one, g of x, which is x, and the other curve from the upper side, it is f of x, which is x square plus 1. So there are two curves and they are passing like this, but I am only interested in this region, and in this region I am only interested in this part, in this shape of the geometry. I am interested to calculate area of this region S, and we have developed a formula to find the area of this region S that is very simple. Integral from A to B, from 0 to 1, the function which is above f of x minus the function which is below g of x into dx. So I can simply replace them with the functions. F of x is x square plus 1 minus g of x is x into dx, and you know how to solve this integral. It will be x cubed by 3 plus x minus x square by 2 on the limits 0 to 1, and when you put them, it becomes 1 by 3 plus 1 minus 1 by 2 minus, every term has 0, so it will become 0. All these will become 0. And when you calculate, the answer is 5 by 6. When I ask you a question, you don't need this. You just do this calculation. This is for your explanation that what is this happening. This region, the value of this whole region, the area of this whole region is 5 by 6. Whatever the units of x and y. If x is measured in meter and y is also measured in meter, then the area of this region is 5 by 6 meters square. Right?
Okay, I have a question.
Yes.
So you write f of x first and then after g of x. How you know which one is
It was
f of
mentioned.
x and which one?
It was mentioned in the second question is very interesting, where it will not be mentioned what is happening, but here it was mentioned that find the area. In the question I have written the whole statement on the pages, you can read them later, but here I didn't write, I just write the equation. It was mentioned that find the area of, and this shape is also not given to you. The question was find the area of the region bounded above by this function and bounded below by this function. So bounded below means the curve coming from the bottom. Bounded above means the curve coming from the upper side. Here bounded above means this is the region, this whole thing S is the region, and this region is bounded above by this part, and this is bounded below by this part. So whatever function belongs to this will be always be written as bounded below. Sometimes they will give you that, sometimes they don't tell you bounded above or bounded below. Sometimes it is written just that if yt is equal to x square plus 1 and if yb is equal to x. So you know that yt means the top function and yb means the bottom function coming from the bottom.
But how we will know that which one is f of x and which one is g of x?
It's up to you. You can decide. These are the symbols. You don't need to you can say this is g of x. Suppose you don't want to make it f of x and you want to make it g of x. Okay, so wait. There were two functions, y equals to x and y equals to x square plus 1. If you want to say the first one is g of x and you are telling me that g of x is x square plus 1 and you are telling me this guy is f of x. Now the information was given to you that this function is bounded above and this function is bounded below. According to the formula, the area under the curve, between the curves is always written like, here you will put the function which is bounded, which is covering the region from the upside. So whatever the name of the function is, here you will put the bounded above function.
Okay.
Minus the bounded below function. Right. So name doesn't matter. These are just the symbols.
Okay.
You can also write area is equal to integral a to b p of x minus q of x dx.
Right.
So you can always change the symbols. Now, one example is find the area bounded by the region, bounded by the curves. That's it. This is the statement of the question. Find the area bounded by the curves y equals to x square and y equals to 2x minus x square. Now the point is, if we know the two curves, then I can find, okay, that is not a problem, that how they are going like this. I can always draw them using my skills of drawing the curves. I can first try to draw this curve by using the values x starting from 0, 1, 2, 3 and so on. I can draw this curve. When I put x is equal to 0, means y is 0. When x is equal to 1, y is 1. X is equal to 2, y is 4. And then you can place those points here and connect them together. For example, this is 0, 0 for x is equal to 0. And when you put x is equal to 1, y equals to 1. Suppose somewhere here, this is 1, 1. And when you put x equals to 2, it becomes 4. Means when x is 2, suppose this is x, this is the point x on x is 2, and corresponding to this, the function y is giving you 4 somewhere here. So you can write it as 2 and 4 and so on. So you can connect them together and you can make a curve like this. Okay, it is going like this. You can always make like this the things. Similarly, you can draw the other curve. Definitely it will go some different path and ultimately they will cut each other. So you can always draw them. The point is that how much the region, they didn't give us AB. They did not give us these 2 points. The data is not provided. So how much this curve for x from 0 to infinity, you can draw this curve up to infinity. Similarly, you can draw this curve up to infinity. Now how much will be the region to calculate this boundary? So how to find those 2 points? That is the question of interest because without having these 2 points, we cannot apply the formula. What is the formula? The formula says area is in between AB, f of x minus g of x. Okay, I can decide which one should be here and which one should be here by drawing them. Suppose one is like this and the other is going like this. So I know that, okay, for this region between here and here, this one is f of x and this one is g of x, because this is greater than this one. So for only for this region, but they did not bound me where. So what will be happening there, and up to where they are going, I don't know. So I have to restrict myself for a certain region. Now in that case, you only need to find the first intersecting points and just find the area under that region. So to find the intersecting points, put both the equations equal to each other. Both are equal to y. So it means you can say x square is equal to 2x minus x square. When you put them together, they will give you certain values of x, which are the intersecting points. Now, when you calculate this whole equation, this is 2x square minus 2x equals to 0. 2 is common, x square minus x equals to 0. I know that 2 is not equal to 0. It means this factor x square minus x is equal to 0. And you can take x common, so x minus 1 is equal to 0. It means either x is equal to 0 or x is equal to 1. So, what does this mean? Anything? Can you tell me after here, is it enough? Is it enough to apply the formula? Is this data enough to apply the formula? No. These are only the values of x. It means they are determining that you can move, you don't know where they will intersect. This shape I have drawn randomly. X is 0, x is equal to 1. They are telling you that the intersection points will be, one will be on the value x is equal to 0 and the other will be on x is equal to 1. If x is equal to 0 is here and x is equal to 1 is here, then what are the intersection points? The corresponding intersection points will be here, and you have to calculate them using the function. So when you put x is equal to 0, it gives you y equals to 0. So the first intersection point is 0, 0. When you put x is equal to 1, it gives you y equals to 1. Any equation, both equations you can try, both will give you the same. It will give you 1. So the second intersection point is 1, 1. Now you exactly know that yes, the curves, whatever their shape is, they are going to intersect at a point here, which is 1, 1, and this is 0, 0. Now I am interested to know the area in this region, which is in between these two intersection points. And to calculate this area, I can move from 0 to 1. X moving from 0 to 1. So integral. Now the function works from 0 to 1, the formula a from 0 to 1. This is what? This is the function for the parabola. Now the second question is how to determine which one is below and which one is above. If you do not want, first thing is you can draw them and decide which one is above. But you don't want to draw them, and you want to decide which one is below and which one is above. Then this equation you know previously. Remember? This equation, you know, what was this equation?
Parabola.
Parabola. It was like this. And between these limit points 0, 1, you have already calculated the area under this curve. Remember?
Yes.
Starting from here up to 1, and we started the integration from this shape
Yes.
by separating into the slices. Anyways, that is not the point of interest here. I just want to recall. This is one equation. Now this equation will go like this. You can draw it, and it is going like this. So, and this is coming from bottom like this. Now this is the region, which is the region of the interest, the S region. Now you can see the function y is equal to x square was written first in the question statement. So in mind it appears that okay, this will be f of x and this will be g of x, but no, here the things are different. You see, y is equal to x square is coming from the bottom. Means the bottom one is y equals to x square. It means this is the g of x as per my formula. You can switch them, but for the convenience we will always consider g of x as the bottom function, f of x as the top function. This curve from the bottom is g of x, and this curve from the upper side is f of x, which is 2x minus x square. So when you are now going to apply the formula, and the formula is f of x minus g of x into dx, you are going to put 0 to 1. You have already decided now which one is f of x. F of x is this guy. So this will be written first, 2x minus x square. And this is g of x, another minus x square, according to this formula, and dx. Now you know how to solve this integral. Do you know?
1/t.
Do you know how to solve this integral?
Yeah.
Help me.
After this 1/t.
Help me. It will be 2x minus 2x square dx. Tell me what will be the answer.